So, hey everyone, I'm Budorick, and I'm an engineer here at Figma. I work mostly on features across our prototyping and editor services, all of our kind of creation services. And I was asked to go talk today about the behind the scenes of how we build and ship features in the editor. So I have this one feature in particular that I'm going to talk about, which we worked on this summer. And this story starts kind of in May during something we call Maker Week. So Maker Week is a thing that we do twice a year where everyone at Figma, everyone, not just the product design and engineering teams, but really everyone drops what we're doing for a whole week and just works on making fun things. So you can work on anything you want as long as it's somewhat related to Figma. You can build a playable Zelda world designer in Figma. You can build a Figma branded Cortal set. You can lead a virtual scone making class. You can create and run a whole Jeopardy game in Figma. You can make jaw-dropping digital paintings at the office because we really miss it. You can write, choreograph, and produce a 20-minute musical with some 40-odd Figmates in it. It's on YouTube. It's great, kind of whatever you want. And of course, you can also hack around on stuff closer to the product if you want. For the engineering team, it's often a fun reason to poke around in other parts of the code base that we don't usually get to work in. And in the run-up to Maker Week, we have a couple different ways to help people seed ideas. We have pitch sessions, and then hopefully I don't get in trouble for this. This year, some of the product team got together and they wrote out a wish list of things that they wish someone would experiment on. So these are sometimes brand new ideas or things we've heard some feedback on that we haven't had a chance to plan or prioritize for whatever reason. They just haven't made it into our short-term roadmap, things that need some design experimentation before we can really figure out what to do with them, or things that we just haven't been able to crack the code on yet. So I take a look at this, and there's only one under the product area called graphics, which is the kind of stuff that I like, and that was spread shadow. And I am an engineer, not a designer, and I'm not a front-end engineer per se, so I actually did not know what that was. So I looked it up, and it seemed like this basically means a shadow, but bigger or smaller. So for example, here is a drop shadow with varying spread values and an inner shadow with varying spread values. So I think to myself, I know how a rendering engine works. I can make a shadow bigger. So I do that, and it takes me about 2 hours. And since Maker Week is virtual this year, we all record Loom videos for our project. So I record a Loom video and upload it, and I move on to my next Maker Week project. End of story. But I had sort of heard about the shadow spread before, and I knew it was kind of like the white whale of Figma. And so I asked someone later that week, hey, why was shadow spread supposed to be hard? And they explained the problem to me, and I realized basically I've done it completely wrong. So here is the problem with shadow spread. We'll start by talking about how we render shadows. So we have two types of shadows, which are drop shadows and inner shadows. Drop shadows are the more straightforward thing. So to draw a drop shadow, we basically copy the shape, but use the shadow's intended color and opacity, apply a blur to it, translate it by some offset, and then render it underneath the shape. Inner shadows are a tiny bit more complicated, but they're still pretty similar. So we take a copy of the shape, blur it, offset it, use these opacities to basically invert the alpha channel of a quad that will cover the area of the whole shape. Mask this with a shape outline and render that on top of the shape. So like I said, my idea was that maybe you take a shadow and scale it up or down, which works just fine for rectangles. But instead, let's look at this A shape. If we were to take this, like a copy of the shape, its shadow, and scale it, we get something like this, and that's probably not what we want, right? Instead, we need to kind of walk out along this perpendicular vector from every point along the edge by X number of pixels, and draw the shadow at the outer edge of all of these segments. So it looks like this. This is probably what we meant by spread shadow, right? So it turns out this is pretty hard to do because these two things are very different geometries. So there's not a simple geometric transform that you can apply to the thing on the left to get the thing on the right. And you can see this a little bit more clearly if we exaggerate the spread more. So now you can see these are really different geometries, right? The thing on the right doesn't have a hole in it. So we can't just reuse the stuff we're already rendering with a simple transform like we can with a rectangle. One approach to doing something like this is sort of an algorithmic approach. This is really computationally expensive, and we thought that it would slow down our rendering engine, which is a cost that we just weren't willing to take yet. And another approach might be to do something like use stroke, but this gets sort of complicated. So for one thing, with strokes, we give you control over how the joins look, but we wouldn't do that with a shadow. So it's not a big problem with this A, which has not super acute angles. But what would we do with something like this star? If we were to fake a spread shadow with the star, then it would look like this if we used our default stroke. That sort of looks like a machine cog or something. It's probably not what you wanted. We could try a round line join, but this looks sort of cartoonish. I don't know if that's what you wanted either. We could decrease the miter limit and let these angles go all the way out to their logical ends. But that is probably not what you intended. If you kind of here, if you like intended to make, say this is 10 pixels, you didn't think this was going to extend all the way to the end here. And I'll also be honest with you and say, like, this is what happens in Figma if you make a really big stroke on a complex vector like this. Obviously, this is like janky. I don't know this is. Actually, I do know what this is. But it's not a good look for strokes, and wouldn't be going for shadows either. I'm actually pretty sure that most design tools will do something like this if you make a really big stroke. So just don't do it. And then the other issue is related to the fact that we actually have two separate rendering engines. One for the editor, which is everything that you see on your canvas when you're creating designs, and all the logic that powers that, and one for the prototype viewer. So we actually generate stroke geometry only in the editor and write it to our files. So the rendering engine that renders prototypes doesn't have stroke generation code. It just reads the geometry from files. So it would have been a much bigger lift to port all of our stroke code to the viewer, the prototype viewer, because it's intentionally lighter so that we can run it on mobile. So we didn't really want to do that. So anyway, basically, I was very embarrassed. So I renamed my Loom video because I couldn't delete it to do not share, does not work, because I didn't want people to see it and get their hopes up, but it was too late. Here's what it looks like to get your CEO's hopes up and disappoint him. He was super excited because someone tweeted this right after Maker Week, and he was like, nice, we're going to do this for real. And I had to say, no, I did this completely wrong. And he was like, great, I'm really looking forward to making this for real. So this happened again the next week. Tom, who leads our developer advocates, was like, hey, I could have sworn I saw this thing. And I said, no, whoops, it would have worked for box shadow, basically like box shadow, but not like text shadow. And then something interesting happened, which is that Tom said, that's kind of interesting. Maybe that's actually good enough. So he said, you know, people use this for like cards and things like that to make them look like they're floating. So enabling it on a circle, rectangular, or frame node seems like it would cover most of the use cases. So I said, it does kind of seem silly if this would cover 90% of use cases, if we could do it easily for rectangles and ellipses, to hold back if we just can't cover like the last 10% of use cases. So we had sort of been working off these presumed product requirements, which were that a field that you add to the shadow effect should maybe work for anything that you can make a shadow on. So that sort of makes sense, right? But maybe in this case, it actually didn't make sense. So we went back to re-examine our product requirements and think about what our users actually wanted. Here's some choice quotes from our users. Considering that shadow spread is something you can do with CSS, I think it's important for Figma to have it implemented. Makes sense. It would be really helpful because our developers have to implement the designs one-to-one, and we have to write the spreads and the tickets every time. And of course, you can build even better shadows. Winky face. Love the encouragement. Figma is perceived as a cheaper tool that doesn't one-to-one match output, thus needing a layer of documentation or communication to assist handoff. Not great. Of course, here's the Spectrum thread that was started in December 2017, where people have been asking us, please, 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 please ship this thing. So we definitely knew about it. Here is a choice quote from that thread. This thread was started 616 days ago. This is the one feature that is preventing me from migrating over to Figma. I'm not interested in jank workarounds that don't translate to developer handoff. Is this actually on your roadmap, or should I stop holding my breath and just stick with Sketch? Ouch. And indeed, like, here's our Asana ticket from August 2017, where we knew we had to build this, but you know, we just hadn't been able to figure out how to do it in a way that would balance performance cost, engineering cost, and product trade-offs. Of course, we knew that people had workarounds for visual effects, and then they also had these crazy workarounds for developer handoff, which are, as our commenter before noted, kind of jank. So here, this user has named the style. Note the CSS is wrong because Figma doesn't support shadow spread, blah, 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 correct CSS, which is a huge bummer. But so all the things I just talked about are related to CSS fidelity and smooth developer handoff. So we decided the most important thing, if the most important thing for users was high fidelity developer handoff, we should look into what CSS actually does. So of the CSS properties that create shadows, box shadow does support spread. Text shadow does not, actually. So the thing that I said earlier to Tom that it wouldn't work for text shadow is like probably okay, right? And then the drop shadow filter, people thought this would work, but it actually does not. The reason people thought it would work was because of the MDN page, which lists spread radius and then says most browsers do not support this, which led a lot of people to believe that maybe eventually they would. This is kind of misleading because actually if you look it up in the W3 spec, it specifically says it does not at all. I'm sorry. The MDN page is a wiki, and so it is mostly right, but if you ever see anything suspicious, you should read the spec. So we decided this is going to work for rectangles and ellipses. Ellipses because you can make an ellipse out of a rectangle in CSS by setting the corner radius to 50%. And we got down to work implementing it. Some things were pretty straightforward. Like I said earlier, making a spread shadow for a simple rectangle, you can more or less just make the rectangle shadow a little bit bigger or smaller. So it's pretty straightforward to scale up this rectangle with a simple transform and it will look right in the end. So that's a pretty common and easy graphics operation. And then there are some things like rounded rectangles that are mostly straightforward, although if you transform a rounded rectangle, it does distort the corners. So we have to regenerate rounded rectangle geometry. But this is still pretty straightforward because rounded rectangles are a very well-defined shape. And the spec says that the corner radius of the shadow should increase or decrease linearly with the spread distance. So if the spread distance is 10, you should add 10 to the corner radius, except for in this one specific case, which is when the border radius is less than the spread distance. You multiply something by this proportion, blah, 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 cubed ratio stuff specific, which the CSS working group had come to via this like very cute sandbox where they tried out all the different options that they could possibly think of for formulas to derive a corner. So it was super specific and intentional, and then it turns out that browsers just don't implement this at all. So the white outline is what kind of they intended it to be, and then the green outline is what it actually is. So they just don't use the cubic formula. I read about a lot of browser code and tickets to try to figure out why this is, and it's just something they haven't done. So the internet is weird and made by humans, and it's kind of messy. And obviously, to build a design tool that people use to emulate the internet, we have to find out all the weird things about the internet and try to emulate them too, which is sort of a fun job, but requires some research and spec reading, and it's sometimes frustrating, but always kind of funny. Another weird thing was ellipses. So this is something that we had some disagreements on, actually. These two shadows are different. You might not be able to tell right now, but the thing on the left, the shadow is created just by scaling an ellipse. So it's still definitionally an ellipse. The thing on the right, the shadow was made by doing sort of the traditional spread shadow kind of walk out along every perpendicular vector thing that I showed earlier. You can see this more clearly if we exaggerate the proportions. So as they grow flatter, you can see more of the difference between the two shadows. I will now show you the end result of that. So here's the final result. You can see that the thing on the left is still an ellipse and the thing on the right is definitely not an ellipse. And which of these is correct? That is up for debate. I think the thing on the right looks like kind of maybe more intuitive, but the thing on the left was a lot easier to implement by like leaps and bounds. And additionally, we decided if we were going for a high fidelity developer handoff, we would do what browsers do. And it turns out that they actually do the thing on the left. So if you make a really flat ellipse with a spread shadow like this, it will create the Eye of Sauron in both CSS and Figma. So then there is a whole class of things where we kind of did need to reinvent the wheel because of the way our shadows already work differently from CSS. For example, if you make a shape with only a stroke and no fill, its shadow is a shadow of only a stroke. So if you imagine like a window frame with a clear pane and a solid frame, the shadow that you'd see behind that is the shadow of the frame. So this is different from CSS, where the shape fully occludes a shadow, even if the shape has a zero opacity background. So it kind of looks okay right now, but if you start layering things together, it does look pretty weird because sort of this counterintuitive like opacity thing going on. As an aside, I know that people wish we did what CSS does because you would rather have this than this. And that does make sense to me. So in Figma, you can see the gray shadow behind this icon that's translucent, has background blur. And people wanted to do this because of design trends, which would be great. However, it's basically impossible to make breaking rendering changes because, you know, if we do something like redesign a UI, you might hate it, but ultimately it still displays your data in a way that makes sense to you. But if we change our rendering output, on the other hand, we're technically not changing your data, but we're absolutely changing the way that you perceive your own data. So that seems like a huge betrayal, and we can't just change the way that we render shadows because it would basically break things for a ton of people who have already designed designs based on the way that they can already use Figma. So if we wanted to do something like this, it would require like an extra layer of complication to say, configure this shadow to be like a knockout shadow or not. By the way, I have no idea if that's on the roadmap. I'm not on that team. I plead the fifth. You should ask someone else. Which brings me back to the stroke thing, which is, what is the correct interpretation of a stroke-only shadow with a spread distance? There's basically 3 different ways you might consider interpreting this. One is that you add X distance to the outside of the shadow, so the outer edge of the shadow ends up looking like the version with the fill, but the inside is still knocked out the same as the non-spread version. Another interpretation might be that you add X distance to the total width of the shadow outline. So you distribute that spread half and half on the outside and the inside. And then a third interpretation would be that you spread X distance from the outer edge and also X distance from the inner edge of the outline. So you ultimately add 2X the spread to the width of the shadow. Like I said, you can't do this in CSS, so it's sort of up to us to define. It's a little bit easier to maybe decide what you think is best if you align the shadows with their nodes, their parent nodes. We did some research on what other design tools do. They do various things. Sketch does the second thing, the middle thing. Framer does a CSS thing where they knock out the shadow behind transparent shapes. XD does not have shadow spread. We decided on the third thing, so none of the above, because we decided that the outer footprint of the shadow should be the same whether or not the node has a fill. Although if you import a sketch file with an outline with a spread shadow, we will import it as a different number so that the visual results look the same. And it's like up for debate what's the right answer here. But like I said, now that we've made this kind of rendering change, we're pretty stuck with it. So I hope it works for you. So yeah, when I wrote the slide, I don't want to sound indifferent about quality. Actually, at Figma, we can be kind of obsessive about quality, maybe to a fault sometimes. And that is actually, I think, what stopped us from shipping this feature a long time ago. So as we worked on this, kind of more and more weird cases came up, and they're a little bit panic-inducing at the time because you think to yourself, like, man, this is an ugly solution, and I wish we didn't have to make this decision. But ultimately, if we wanted to ship this feature, we kind of had to power through these solutions that are good enough and can unblock us. So things like if you make a shadow of a gradient with 0 opacity areas, the shadow will look like this. So every pixel that has an opacity of 1% or higher gets a full opacity shadow, and every pixel that has an opacity of 0% gets no shadow. This is kind of weird, but this is how it works. So we couldn't, because we didn't implement the sort of algorithmic approach to spread shadow, we couldn't make kind of walk out from all these individual geometries in the shadow. So we decided that if you add a spread value to any of these shapes, we'll just automatically convert the shadows to full opacity shapes, rectangles or ellipses or whatever you're using. Similarly, frames with clip content disabled become problematic. I don't know if you can read that. It says only supported for frames or components when clip content is enabled, because here, the overflowing contents can contribute to the drop shadow, and we just don't have any code that can correctly sort of implement a spread shadow for those overflowing letters. So we just don't let you do spread shadows for these. Same thing for frames with no visible fills. If you don't have any visible fill paints, then the shadow of a frame would be the shadow of its contents rather than the shadow of sort of the frame footprint. So we just don't let you do that. So we thought this would take about well, I thought it would take about 2 weeks to ship because I'm optimistic and bad at estimating. It took about a month and a half. But the process of adding features to Figma, like a sort of a full stack rendering feature like this, is added to the file schema from which kind of all these other things cascade. You can add it to our editor, which is in C++, the UI layers in TypeScript, the prototype viewer, plugin validation, file import, rendering tests, REST API. And then within the editor, that code base is responsible for rendering, SVG export, CSS export, PDF and image export. And of course, before we do anything to the UI layer, we have to be intentional about our redesign. I'll be honest and say, when I made this feature for Maker Week, I just took our shadow panel on the left and turned it into this. And I thought, this is like, good enough for now. And thankfully, I worked with some talented designers who were like, no, we will send someone to help you. So for one thing, obviously, it was already kind of weird that our shadow panel didn't have the canonical order, which is XY blur or XY blur spread. So in addition to sort of reordering those, we wanted to take the time to kind of reimagine what this might look like. This was actually something I worked on with Raji, who you know from introducing me today, and or because he's famous on design Twitter, maybe. And so it's a super thorough redesign of our code panel, of our shadow panel. One idea was maybe we could inline everything with the canonical order like this, XY blur spread. It would all fit on one line, but ultimately the things on the right maybe don't have enough information. Another idea was to inline these in the properties panel on the right, but again, looks nice, pretty clean, maybe not information about BS. Another idea here, now it kind of does the canonical order XY blur spread, but we didn't like how the labels of the X and blur and the Y and spread align kind of weirdly. To fix that, Raji tried all different kinds of icons which are beautiful, but ultimately we decided didn't communicate enough. And so we landed on XY blur spread, but the tab order goes top to bottom, so it still works in the canonical way that you'd expect. We do gate all of our changes behind sort of a gate on the back end so that we can turn off code on production whenever we want to, or turn on code. So there's plenty of code for spread shadows that we ship to production that we just kind of had turned off for like a month before we actually released the feature. We did not turn off the redesign, so we just kind of turned off the spread field here. So it's kind of a fun Easter egg. This Twitter user astutely observed that something might be coming to the shadow panel soon. He was correct. So that's kind of fun. We had rendering tests that are like every combination of things that we can think of that you might do with a spread shadow. So, you know, inner shadows, drop shadows, big shadows, small shadows, all kinds of fills, all kinds of shapes. And then we test every change that we make against our whole suite of rendering tests to make sure that we don't introduce rendering regressions. We also get together, everyone who's working on the project, and do a bug bash, which is we kind of all play around in one file and try to break our feature. So just like make a bunch of shapes, do all the things that we think that users could possibly do on accident or on purpose, and see what breaks, file bugs, and fix them before we launch. Of course, it's impossible to fix everything before we launch. Some bugs happen. Here is Tom on launch day saying, interesting, this broke one of my plugins, not a complaint. Tom is not complaining because Tom is Canadian. And actually it kind of had broken all of the plugins that add shadows without spread value. So that was not good. Thankfully, we were able to hotfix it that day, and that turned out to be okay. So this kind of seems like a simple feature, but it still ends up being a pretty involved project. Obviously, some features are more straightforward than this, and some are much more complicated. So hopefully you will go to the variants and auto layout talks today, which are much more complicated features. But yeah, it's still kind of important to be this thorough for even sort of a small feature, because ultimately this is a thing that tons of people work in every day. And if we interrupt your workday with bugs or unexpected things or things that don't make sense, that is on us, and you should be mad at us. So we try to be super thorough and kind of fix everything we can. Yeah, I hope you have learned something or found that interesting. If you ever want to talk about shadows or dogs or maps, I'm on Twitter at Budorick. Thank you.